It seemed as though the mounds had appeared overnight. Daniel Mercer had walked this stretch of prairie 100 times before, and he knew the land the way a rancher knows the back of his own hand. So when he crested the low rise east of Section 26 that April morning and saw them, hundreds of freshly turned earthen craters scattered across ground that had been empty weeks before, he stopped walking. No claw marks large enough for a badger, no obvious burrow architecture he recognized from the survey manuals. He knelt down, ran his fingers through the loose soil, and wrote 4 words in his field notebook that would end up mattering more than he could have guessed. These burrows weren't here last season. You need to know what this land used to be in order to comprehend why the message finally reached Dr. Elena Ruiz, a restoration ecologist, and why it took her almost 3 more years to realize what it meant. Northeast of Denver, beneath the shadow of the Front Range, sits a piece of land that spent half a century as one of the most contaminated places on the continent. During World War II, the U.S. Army built the Rocky Mountain Arsenal here to manufacture chemical weapons, nerve agents, mustard-related compounds, incendiary materials. When the fighting ended, private industry moved in behind the military and used the same infrastructure to produce pesticides, and for decades, the ground and water absorbed the runoff. By the 1980s, federal investigators had labeled sections of the arsenal among the most polluted square miles in the nation. It was the wasteland at the edge of the city, ringed by fences and warning signs, a landscape that seemed permanently disqualified from ever supporting life again. The federal government and its industrial partners had spent over $2 billion scraping, treating, and containing the contamination by the time cleanup workers completed the final phase of remediation in the early 2010s. This was one of the most costly environmental remediation projects ever carried out on American soil. In 1992, Congress had already taken the extraordinary step of designating the site a national wildlife refuge, a decision many Denver residents found almost absurd at the time. But within 2 decades, visitors driving the loop road could watch bison graze against a skyline of skyscrapers, and for the ecologists who had spent their careers here, that view felt like vindication. Clean the poison, plant the grass, watch the wildlife come home. Case closed. It wasn't. Elena Ruiz, who joined the restoration team in its final years, was among the first to notice cracks in the tidy success story. Her early monitoring looked encouraging. Contamination down to safe levels, native grasses reseeded across thousands of acres at a cost in the tens of millions, bald eagles nesting along First Creek. For one field season, she believed the hardest part was over. Then she cross-referenced her biodiversity transects against the reseeding maps, and the numbers unraveled. Insect counts were a fraction of what healthy prairie should support. Ground-nesting birds her models predicted simply weren't there. Coyotes and raptors passed through but never stayed. The grass had returned. Almost nothing else had. She wrote the question into her notes almost verbatim. If the ground is clean and the grass is growing, why does this place still feel empty? It wasn't chemistry anymore. Toxicology had already answered that. Underneath sat a suspicion she couldn't yet name. Something structural was missing from how the land itself was built, something happening below the surface rather than above it. For 2 years, Ruiz's team chased that suspicion down every conventional path, and each one led somewhere different than the hunch pointed. Maybe the grasses needed more time to mature, but decade-old plots showed no more diversity than 5-year-old ones. Maybe remediation had left subtle chemical imbalances discouraging insects, but soil chemistry tested normal. She collared coyotes, hoping predator presence might anchor the food web, and watched them wander through the quiet zones without settling, unwilling to hunt ground that looked green but offered nothing. Each result was careful, publishable science. Each one widened the mystery instead of narrowing it. Around then, Daniel Mercer's name began appearing in her correspondence. Not a scientist, but a ranger on the ground every week, the kind who noticed things instruments missed. That season, he sent Ruiz a note about a stretch near the refuge's northern boundary that seemed to be thriving. More birds, more insect activity, though he couldn't explain why. She flagged the coordinates and moved on, still chasing chemistry and predators. It would be nearly 2 years before she circled back, and when she did, that unremarkable patch held one of the investigation's most important clues. The break came from tedious comparison rather than a single discovery. Frustrated after 2 years of eliminated hypotheses, Ruiz stopped asking why the refuge as a whole was underperforming and started asking a narrower question. Were there any patches actually thriving, and what did they share? She mapped outliers across 8 years of transects. Most of the refuge told a flat, disappointing story. But a handful of scattered patches, including Mercer's northern stretch, stood out sharply. Higher plant diversity, denser insect activity, burrowing owls nesting in numbers nowhere else could match. For a few weeks, she felt real optimism. She had a pattern. She just needed the thread connecting it. The optimism didn't survive contact with the data for long. It wasn't proximity to water. Some thriving patches sat nowhere near a creek. It wasn't soil type, which varied little across the refuge. It wasn't reseeding density, since some vibrant patches had gotten the same seed mix as sections that stayed lifeless. Whatever was setting these pockets apart, it wasn't in the management record. Ruiz has described the feeling as staring at a pattern she could see perfectly and understand not at all, as if the land were following a rule nobody had written down. The rule had been sitting in the ground the whole time. When Ruiz finally walked Mercer's flagged patch herself, she found burrows, dozens of them, connected by worn paths, exactly the kind of feature he'd logged years earlier across the refuge. Every one of her thriving outlier patches sat on or beside an active burrow colony. Not bison range, not a soil treatment. Colonies of small burrowing rodents doing something her monitoring program had never been designed to measure: prairie dogs. If you're picturing a triumphant reveal, picture the opposite. Ruiz's first reaction was closer to disappointment than excitement. Prairie dogs are about as unglamorous as North American wildlife gets. They don't draw tourists the way bison or bald eagles do, and ranchers across the West have spent over a century treating them as pests. Government-sponsored poisoning campaigns wiped out an estimated 95% or more of the historic population during the 20th century, clearing hundreds of millions of acres of colonies down to isolated remnants. Compared to a black-footed ferret, a prairie dog looked, to Ruiz, like an answer too small for the size of the question. Colleagues pushed back hard. If it were simply about digging holes, why hadn't badgers produced the same effect? Why not ground squirrels, common across the same terrain? Why not rabbits, which outnumbered prairie dogs on parts of the refuge? For every acre of owl habitat Ruiz pointed to, someone had a competing burrower that should have done the same job and hadn't. The first reveal didn't close the mystery, it reopened it under a new name. The question was no longer what set these patches apart, but why this species alone could produce the effect. Answering that meant abandoning the idea that the prairie dog itself was the discovery. And Ruiz calls this the moment the investigation actually got interesting. Unlike a badger's solitary den or a rabbit's shallow scrape, a prairie dog town is a sprawling engineering project, sometimes spanning dozens of acres, and housing thousands of animals in tunnel networks running 6 feet deep and 30 feet long. A single established colony can move tons of subsoil in just a few years, reworking the ground's physical structure in a way no badger or rabbit ever could. That reworking triggers a slow chain reaction. Burrowing loosens compacted earth, letting oxygen and rainwater penetrate soil, sealed for decades by the site's industrial history. Deeper water lets deeper roots establish, letting more plant species compete. Greater plant diversity supports more pollinating and burrowing insects. Insect abundance draws burrowing owls, which nest almost exclusively in abandoned prairie dog burrows since they can't dig their own, and those owls become prey-supporting ferruginous hawks. Prairie dogs themselves feed several refuge predators, and black-footed ferrets, the arsenal's most publicized conservation success, depend on them both as prey and as shelter. It's a documented relationship. Ecologists classify prairie dogs among the clearest examples of a keystone species. Ruiz's team had, without meaning to, produced one of the cleanest field demonstrations of it ever recorded on a formerly contaminated site. A chain of plausible steps isn't proof though, so Ruiz turned the theory into predictions and went looking for reasons to be wrong. Plant diversity should track colony boundaries. It did. Bird communities should follow the same pattern. They did, with owl nesting success concentrated almost entirely around established colonies. Predator territories should stabilize wherever colonies persisted for years. They did. And ferret breeding success, the refuge's most closely watched metric, should correlate directly with colony density. It did, almost precisely, with reintroductions failing repeatedly in thin colony sections and kits surviving generation after generation wherever colonies were robust. 4 predictions, 4 confirmations. Ruiz still says it's the only hypothesis in her career that survived every test without a single surprising exception, which made her more suspicious of it, not less, until the pattern held through a 3rd breeding season. The finding didn't stay contained to 17 square miles outside Denver. Across the West, wildlife agencies have spent decades and an estimated $45 million reintroducing captive-bred ferrets into seemingly suitable habitat, only to watch many attempts fail where prairie dog colonies were too small or too actively managed against. The arsenal became one of the clearest natural experiments proving what ecologists had long suspected but rarely demonstrated so cleanly. You cannot rebuild a grassland ecosystem by cleaning contamination and planting grass seed alone. You have to restore the underground architecture and the animal that builds it. That conclusion carried an uncomfortable price tag. Agencies have poured well over $2.2 billion into remediation alone, plus an additional $35 million more into reseeding and reintroduction. Yet by Ruiz's own assessment, the gains that finally let ferrets breed and raptors return came not from another funding round, but from letting prairie dog colonies expand largely undisturbed across a few thousand acres. It's the kind of cost versus nature contrast that recurs throughout conservation science, though rarely this starkly. A multi-billion-dollar cleanup created the conditions for recovery, but an unglamorous rodent working for free did the actual rebuilding. That contrast hasn't settled anything beyond the Refuge fence line. Prairie dogs remain genuinely contested across Colorado, and the same weeks Ruiz prepared to publish, a rancher family bordering the Refuge's western edge was lobbying county officials for expanded control after a colony spread onto grazing land they leased. Their argument was neither irrational nor new. Colonies compete with cattle for forage, and an unchecked town can outpace any fence. Poisoning and control programs continue across the region, costing landowners anywhere from $5,000 to $15,000 annually in real money. Conservationists counter that well-managed colonies can improve forage quality over time and provide services, pollinator support, water infiltration, rodent control, that never show up on anyone's balance sheet. Ruiz has sat in rooms with both sides and left without a tidy resolution. What her research does is harder to dismiss than an opinion. It asks people who've spent a century treating this animal as a liability to hold 2 things at once: that prairie dogs can hurt a rancher's bottom line, and that the same animal may be essential to rebuilding the ecosystems agencies spend billions trying to restore. It's worth pausing on how easily this could have been missed. Buried in the Refuge's own monitoring archive was a detail earlier survey teams had noted in passing and never followed. Surveys from the early 2000s documenting unusually high owl nesting success in a handful of plots never cross-referenced against colony maps. It took nearly 2 decades, a notation in a ranger's notebook, and one ecologist stubborn enough to keep asking why a clean green landscape still felt empty before anyone connected that overlooked data point to the pattern reshaping the rest of the refuge. Some of the most important discoveries in ecology aren't made in a single moment of insight. They're made by noticing that a detail dismissed decades earlier was the answer all along. The significance hasn't stayed contained to one refuge. What started as Mercer's forward field note is now cited in restoration projects across the Great Plains, from former farmland in Kansas and Nebraska being converted back to grassland, to other decommissioned military sites confronting the same assumption the Arsenal's team once made, that clean ground is the same as living ground. Agencies managing ferret recovery across multiple states now weigh colony health as a primary indicator of success. A story that began with a few thousand acres of contaminated prairie has become part of a much larger conversation about how the country approaches ecological restoration. None of this happened quickly. The Arsenal's transformation spans more than 80 years. Wartime manufacturing in the early 1940s, decades of pesticide production, a federal cleanup launched in the late 1980s, running into the 2010s, and a ferret program, now more than 2 decades old, with mixed but improving results. Beneath that human timeline sits an older one. Black-tailed prairie dog colonies have shaped shortgrass prairie for thousands of years, evolving alongside bison and native grasses. What happened at the Arsenal wasn't invention, it was reactivation, something ancient, waiting for the poison and fences to lift long enough to start again. That raises a question, keeps circling but never fully answers, because no one studying the refuge can answer it with certainty. Teams now monitor colony boundaries, the way earlier generations tracked contamination plumes. Mercer himself still walks the routes he first mapped, naming the season each colony appeared. Sections with promising ferret activity 2 years ago have gone quiet, hit by sylvatic plague, which can wipe out entire colonies in weeks. Other sections, once biologically dead, now show the same burrow architecture that once seemed out of place. The refuge isn't finished. It's a living negotiation between contamination mostly contained and an ecology still rebuilding itself, colony by colony. What Ruiz eventually understood, after years chasing an answer she assumed would be chemical, was a shift in how she thought about restoration itself. She'd set out believing her job was rebuilding an ecosystem piece by piece, like reassembling a machine from a parts list. What she found instead was that ecosystems aren't machines. They're relationships, built over thousands of years of coevolution, and no amount of clean soil or planted grass can substitute once those relationships break. Humans can remove damage, excavate contaminated soil, treat groundwater, reseed a hillside, spending billions doing it well. What they can't do is manufacture relationships that took millennia to evolve. The cleanup made recovery possible. It didn't make recovery happen. The greatest discovery from one of America's most expensive restoration projects wasn't a technique for rebuilding nature. It was recognizing that nature already knew how to rebuild itself once its old relationships were allowed to function again, and that the humans standing over it were never really the ones doing the building. Today, if you drive the wildlife loop at dawn, you'll likely see bison moving across a horizon, oblivious to the fact that the ground beneath them once produced some of the most dangerous chemical compounds ever made on American soil. You might catch a burrowing owl at the mouth of a tunnel it didn't dig, watching for hawks it depends on, and fears in equal measure. Somewhere beneath the grass, a network of prairie dog burrows is quietly doing what it has done for millennia, moving soil, moving water, moving life back into ground once declared beyond saving. Whether that process holds, whether it spreads to the sections still waiting for their first colony, whether disease or drought or renewed interference sets it back again, nobody watching this land right now, not Ruiz, not Mercer, not the ranchers still weighing what to do about the colony on their fence line, can say for certain. The investigation isn't closed. It never really is. Not in a landscape this complicated, this scarred, this stubbornly alive. If you want to keep following where the story goes next, because there is more coming, more mysteries buried in landscapes just like this one, all over the world, that's exactly what our channel is here for. So stay close, subscribe, and come back for the next investigation, because out on that quiet Colorado prairie, the ground is still moving, and nobody is entirely sure yet what it's going to build.